Okay, we have here another example where I am not showing you a picture. I'm just giving you some information about the triangle, and I'm saying, hey guys, can you solve the triangle given what I'm telling you here? And we've done this for law of sines in the past. In this case, you should see right away, this is a law of cosines problem. The dead giveaway is that there's no angles. So how can you have a matching pair of angle side if there's no angles present? So you have to do law of cosines on this. And as soon as you decide it's law of cosines, that means these things down here are all going to be DNE. Okay, so that part should be very quick once you've decided this is law of cosines, which is why categorizing your triangle is an important skill to have early on. It saves you some time that you might waste trying to do law of sines when it's not appropriate. So I'm going to go through how you would solve this one using law of cosines, but I also want to just imagine for a moment that one of these was actually an angle. Okay, like let's say that were angle B equals, I don't know, 40 degrees. Okay, if that were angle B equals 40 degrees, this would still be a law of cosines problem because I still don't have a matching pair, right? I've got angle B, side A, side C. There's no repeat letters. So again, it's law of cosines, and this stuff is still crossed out. All right? So moving on with the actual example that we've got here, okay, where I have three sides. If you had an angle, your first task would be to find the third side. So now I'm just starting with three sides as if that's what I'm given. And what I'm going to do is write down one of those laws of cosines. There's several different versions of this, right? But I have this law that says cosine A equals, and this one's a little harder for me to remember. I don't know about you guys, but it's b squared plus c squared. So the two sides that don't match the angle minus the side that does match it, b squared plus c squared minus a squared over 2bc. Okay, that's my cosine of A. And if I then do the inverse cosine, I'm going to find my angle. So let's see what I get there. Typey. Where is my... Here we go. There's my window right there. Okay, so I do some typing here, and I'm doing the fraction. Remember, I always do just the numerator. I figure out what that number is, and then I divide it by the bottom number. It helps me not make dumb calculator mistakes. Okay, so I found that, and now I do the inverse cosine, and we get, looks like 30.27 degrees. Okay, do the exact same procedure for another angle. Pick B. Now, a word of caution, you could switch into the law of sines at this point, but I always recommend against that. It's a fine way of doing it if you know what you're doing. If you choose the wrong angles to solve first, you might accidentally make yourself an ambiguous case where there should not be an ambiguous case. Okay, you might accidentally wander into something kind of nasty. So that's why I just tend to stick with law of cosines when I'm in a law of cosines problem and not switch back and forth. So I would use the next law of cosines, which, let's see, here, I've got a little space down here. Let's write another one. I would say, okay, let's go for angle B. Cosine of B equals a squared plus c squared minus little b squared over 2ac. Okay, so we type in some things, and again, I'm going to do the top first. I'm going to square that all out, and then I divide it by the bottom here, and the important part at the end is do inverse cosine, and I get 72.88 degrees. Okay. So now at this point, you can find angle C, and if you're in a test with a little extra time, I would recommend doing the same procedure that I just did to find angle C, because it's a useful way to double check that you're doing everything right. If you calculate A, B, and C using the law of cosines, and the sum of those angles is 180, you know you got it right. But if you just then, if instead you found angle A and angle B and said, oh, I feel so great, I'm just going to calculate what C is by seeing what 180 minus these guys is. So if you just then move on to this point, here's what I'm talking about. If you say C equals 180 minus A minus B, well, that statement is true. But what if you made a mistake in angle B? Then your angle C will also be wrong. You're going to have like 2 out of 3 incorrect angles in here, and you're not going to get very much credit. So I would recommend find every angle the hard way using the formula, and use the fact that they should add up to 180 degrees as your sanity check at the end. That is really one way you have of checking these that you won't always have with math problems. You should have a way to know for sure that you're right. All right. So there we go. I have that. Remember, this stuff is all D&Es down here because it's law of cosines. And when you're doing law of cosines, there's no ambiguity. Okay, it can't exist down here. And then, I mean, obviously, you just take these and put them over here. Okay, those were given to you.